Hello, Abhijit sir. Good afternoon. Yeah. Okay, sir. So I think sufficient participants has already joined. So I think you can start your session.
Yeah. Yes, sir.
Yeah, please. So dear participant, just Dr. Abhijit sir is just starting his session. So please be here and please don't try to unmute yourself during the session. It really creates disturbances in between. So we are starting the post-lunch session here, and after this particular session, we will have the valedictory, and just after that we will circulate the link for online test quiz. So please appear into that. Good wishes. Thank you.
Sharing screen. It is visible. Is it visible to all?
Screen is visible but not PPT. Yes. Now it is coming. Yes.
Yeah. Yeah. So once again, thank you, Dr. Ravi sir, and all the organizing committee of this special FDP. Thank you very much. And
Yeah.
I must congratulate at I think this of this FDP. So, sir, from my side, I wish you congratulate for the success of this FDP, and to all the participants as well. So, let us start our last session of this FDP, and which is on pre-processing. As you know, 3D printing. Now you are well aware about the 3D printing, concept about 3D printing. What are the various application of 3D printing, and multiple things you have gone through. But guys, for 3D printing, some softwares or tools, and before that, some things are the pre-processing are very much important for the manufacturing of it. That's why just we kept this session on pre-processing. Like I have given the name ABC of 3D printing pre-processing, so that we are going to discuss a couple of fundamentals about the pre-processing of 3D printing, which will be on mesh mixer and slicing tools. Means before the manufacturing, right? So where by layer manner. This is a so, but now as an input, STL as an input, the 3D printing took place like layer by layer in additive manufacturing, additive process. That's why it is known as additive manufacturing, right? So for 3D printing, dedicatedly on biomedical applications, right? Medical application that this FDP was dedicatedly on that. So what are the things you will require? If you are aware now, when digital history coming into a picture, just only a 3D printer you required. 3D printer. It may be FDM, it may be a resin printer. In dentistry, resin printing is more widely used. Whether it is a Formlabs 3D printer, whether it is a Formlabs 3D printer, any cubic 3D printer, right? Those resin printers are widely used in dentistry, and so 3D printer you can use. Means it will require the 3D printer. Another computer, obviously computer. For what? For those softwares. And another digital things. Apart from that, you got the thermoform, the aligners, aligners. Then after creation of model, you will require the thermoforming sheet and thermoforming machine, so that you can develop those clear aligner sets for orthodontic applications. This is the last. We have the quiz and then validatory functions. So I'm keeping my session on little pace. Is it visible or is it visible? Slides are visible?
No, sir. No, sir.
No, sir.
Abhijit sir, I think screen is gone, so please reshare again. No issue, I think it is a connectivity issue, something, no issue. Please reshare. And...
As I told you, yes, yes.
Yeah, no.
Now, is it visible, sir? Anybody,
No,
please?
sir.
No, the slide is visible.
Actually, sir, it is loading.
Actually, I'm at one remote place and joined from my mobile internet, not from web, but doing. From my side, it is showing. But just a second.
The same, sir.
Just a second. Just 2 minutes, please.
Yes, sir. Yes.
Now?
Yes, sir. It's visible now, sir.
Yeah, thank you. Okay, so this is the workflow of 3D printing. Hope now it is, if anyone will ask you anytime and give the answer, what is the workflow of process of the 3D printing. The first and most important, for any product development, or for anything, pre-processing or first initial steps are much important, right? So that's why pre-processing is important, means before the manufacturing. So, and the first step for pre-processing or 3D printing is what? Creation of model, 3D model. CAD modeling is the first. Then we export, we generate the STL file, right? Whether it is ASCII or binary, we generate the STL file. After that, from CAD software, then we import to slicing software, and then after the G code, means this is the overall process which we are going to discuss, right? So first step is CAD modeling, right? As we are discussing, if you are aware that CAD modeling, there are various we can say alternative of CAD modeling. First, as an engineer, most of engineers are well aware that various tooling softwares are there, tools are there for engineering related CAD, whether it is modeling of building, modeling of any machine component, right? For that, there are various engineering CAD, like whether it is Creo, CATIA, SolidWorks, right? We are going to discuss in detail. And then this is the industrial and engineering applications. But for the medical, on which we are more focusing in this particular FDP, the medical CAD, like we can say biomedical. For that, various toolings are there. And for CAD modeling, in some of the other field, we can say like sculpturing, you need to replicate the antique things, or even in automobile engineering, automobile companies, even in automobile companies to get the CAD modeling of the older chassis or whatever component of automobile. So there is a reverse engineering concept, right? 3D scanner, right? So these are the things. These are the first step of 3D printing, we can say, for CAD modeling, not only in the engineering CAD, right? So as we know, for engineering CAD, there are various softwares. If you are well aware or not, you can note it down. There are CATIA, Creo. These are the professional softwares. SolidWorks. These are the professional softwares which are widely commercial software, which are widely used in industry. But at the same time, most of the time, audience ask us, or even from the medical fraternity, because they can't purchase, or they don't have the facility of those commercial software in their institution. Every engineering college is having the CAD software, but they don't. But there are various open source software also, free software like a Blender. Blender you can note down. Free CAD software is there. SketchUp, Google is also having his CAD software like Google SketchUp. So these are the open source or free softwares. If you are aware, the initiative of NIT Aayog, they have introduced this 3D printing for the schooling educations also. ATAL Tinkering Lab, that one of the government NITI Aayog government of India's project is there. In NITI Aayog ATAL Tinkering Lab, in schools, they are teaching the CAD on Thingiverse. No. Just forget it. We'll get just एक अपना छोटा सॉफ्टवेयर है ना, but है मुझे क्लिक नहीं हो रहा. So they are in school also, they are using the CAD softwares, right? So these are the various CAD tools which you can use. Apart from that, as I told you, the dentist or medical fraternity are using CAD as a pre-processing for 3D printing. So these are the softwares like Blue Sky Bio. Blue Sky Bio is one of the software which is used for the clear aligners or for preparation of surgical guides, right? In my last session, I have shown the various application of 3D printing, especially on which we have worked. So Blue Sky Bio, you can note it down. Blue Sky Bio is free software. Like to all the dentists or doctors, the 3 exports are free, where you can perform all the planning related things. Otherwise, there are various paid or commercial software like 3Shape. 3Shape Studio, Implant Studio is there. It's a commercial software, right? Exoplan is also there. It is also paid software. But Blue Sky Bio, it is giving like a 3 export where you can plan whether it is surgical guide, whether it is micro guide, whether it is a denture, whether it is denture or whether it is aligner. You can plan on it, on it. So you can note it down. These are the free software for biomedical planning, right? So after that, so these are the engineering softwares. After that, as you know, for biomedical CAD, there are various softwares. Mimic, professional software, Mimic, Thematic, means Materialize. From Materialize, there are software Mimic and Thematic. Even 3D System, which is the pioneer company of in 3D printing industry, there is a D2P software. for biomedical CAD. Like what happens in biomedical CAD, we convert CT scan data, MRI data into STL file, right? So we are converting CT scan and the CT scan data, DICOM data into a 3D printing, the STL, which is the first essential file for the 3D printing. But at the same time, these are the paid software, Mimic and D2P software. So at the same time, there are open source software which is very useful. I have enlisted for your knowledge. 3D Slicer is there, Invisalign is there. So you put your CT scan data into a STL. So you can note it down. After that, the process of this biomedical CAD, CT scan data, we are converting into a DICOM data, and then Slicer converts that STL into G code, which we use to give the 3D printer, right? But guys, when we convert, whenever pathologist used to take the scan of this mouth or of any organ, right? Whether it is 3D scan, means intraoral scan, or external scan, reverse engineering. While taking the input, it is taking the other areas also, means scanning the other areas also. In industry, people used to say it is a noise, means unnecessary or unwanted area, which converts into a STL. So that's why we can't directly go for the 3D printing. We can't go directly to the 3D printing. Pre-processing is essential. If we are starting from engineering CAD, so all optimization can be done in engineering CAD software itself. But while for biomedical application, and if we are importing the data from CT scan or MRI, or we are creating, we are planning something on those particular software, further the STL processing is important, right? For that, there are various tools. Another thing, another means for this processing means to removing the noise or to cut those parts, whatever things are needed. And for another, some of the non-engineering people or even students are directly printing, directly downloading those STL files from web, from internet. So many times those STL files get corrupted. Get corrupted means what? Some of the triangles, means, as you know, STL file is a standard triangular language or standard tessellation language. If single corner or single edge will be what we can say cut it out or missed, then it will shows the error. So for that also, these editing softwares, these pre-processing softwares are very much essential, guys. Otherwise, if we directly go for the printing, 3D printing, it will give error, or what happen, or it will directly all those material and time will be wasted. So there are various editing software, STL editing software, like you can note it down: Mesh Mixer, MeshLab, MATLAB, NetFab. And all these are open source software. NetFab is also good software. It is open source software. Mesh Mixer, which is widely used in medical industry, especially in dentistry. So Autodex, the Autodex, the renowned company in this industry, is having this software, Mesh Mixer software, right? So we are in short going to take the introduction of Mesh Mixer in this particular session, right? So hope you have noted down this details. As I told you, you know about the hello.
ये तो इस पे निशान आ जाता है के
Hello, anything? Hello. 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 Okay. So as you know, as we have discussed, standard triangle language or triangular language, I have told you if any face or edge will get corrupted or cut, it will gives the error, right? Just standard triangular language. Next. So let us start. So these were the introduction. So let us take the overview of that particular software. Is it visible? GUI, Mesh Mixer GUI.
Yes, sir.
Is it
It's
visible?
visible, sir.
Yeah.
Generic 3D printing process slide is visible.
No. Software GUI, Mesh Mixer, ma'am.
No,
Wait,
not visible.
I'll share
Generic
it.
3D
Slides
printing
are
process
visible.
slide is visible, sir.
I'll share it. Okay. Now, is it visible, ma'am?
Things like import and open.
Yeah. Okay.
Right, sir.
Means we are on the right way.
Right, sir.
So this is the GUI, graphics user interface or environment of that one of the essential pre-processing tool for 3D printing, which is I said Mesh Mixer, right? So this is the environment. You can download it from Google. It is open source. You can freely you can get it at no cost, right? So as I told you, once you have imported that STL, means once you have converted that DICOM into STL, right? Or you have directly downloaded that particular file from web, and you have some whether it is mandible, maxilla, ear, nose, whatever file you have. So you need to first import that file here, right, in this particular environment. So you can see here is there is an option open and import, right? So it supports various files, obj, right, stl files. You can open that and you can import that particular file. So click on import. I have kept one mandible file, so just give a path and it will generate a mesh. In this way you can import that particular stl file in this environment, right? So after that, if you are aware that we need to 3D print it further, so there are various options. Uh, you can go to view. There is an option view. So there is a wireframe, show wireframe option. So you can see this, as you know, as we said, S standard triangular language. So you can see this mesh file, right? Standard triangular language, and the shortcut for it is W. If you press the W, it will directly take the command. And if you are aware about the FEA, right, finite element method, ANSYS, if you have used, right, meshing is more important. Agar meshing zyada, if there is a what we can say fine meshing, then results are good, right? Same here. If we increase the meshing, the file accuracy or further editing is very much good. It will be much better, right? So you can click the wireframe view from here, and if you would like to, if you are this meshing, otherwise you can select that particular file. There is a select option. You can see. Hope my arrow is visible. Select, then double click. Once you have double click, there is an edit option. Okay, edit, and then there is a remesh. Got it? So if you would like to increase the meshing or reduce the meshing, in this way you can get it, right? Click on mesh. It will take as per your STL file or complexity of that particular file, your software will take the time, right? Now you can see this, the close the option density. You can increase this density of this file I'm not, I'm avoiding this because it will take much time. So cancel. Okay. So I'm I'm giving the overview. Just you need to change the density. So it will give the find. Hello.
क्या देख रहे हो?
वर्कशॉप चल रही है कौन है?
Hello. So in this way, you can increase the mesh, right? So that you can get the better result from these icons. Okay. So मैं इसको बंद कर रहा हूँ. At the same time, in view command itself, there is option show printer bed. After all, you are going to print it on 3D printer, right? So click on that. Once you have clicked on that particular command, hang हो गया क्या? You can see there is a pre-default 3D printers available in this library of mesh mixer. You can select whichever 3D printer you have, and you can analyze your STL model whether it is on bigger in size or the position of that particular STL file, right? So at this time, I'm removing it. Okay, that is. Hope this thing clear. These things are clear. Next, another thing, whenever you input this file is much we can say smoother or good enough, but if you import it from web or scan, then some pre-processing is required, as I told you. If you need to give it the proper finish, smoothing, so that the accuracy, output accuracy of your print shall be good. So okay, so what you need to do, just there is an option sculpt, like sculpturing. If you are aware, like there are various sculpturing softwares also. We have not enlisted in that, like Creo, Katia. There is a ZBrush software, ZBrush Rhino, right? 3DX Max. So even those features are available. That 3D figuring or sculpturing commands or features are available in this mesh mixer also. Like so, if you need to smoothen that, but hello. So sculpturing tool, you can see there are various options. I am discussing important options over here because there are multiple options available, but we don't have that much time. So I'm just giving the overview. I'm just giving the overview about the essential options only, which will be helpful for the pre-processing of that particular STL, right? So there is as I told you, just if you would like to finish that particular this tooth, right? If it is having irregular geometry, right? So click on sculpt. There is an option brushes, right? So you can smooth by using smooth command, bubble smooth command. You can click over here and see the result. आप देख रहे हो? Even this there is a hole, right? See this. Right? So in that way, you can smooth out the structure, and there is a size. See this. So you can opt for the bigger size of that particular tool so that maximum area can be covered, right? And when you required smaller in size, so size can be changed. Okay, that particular operation, the tool size, even strength also you can edit. Means the we can say strength or depth of that particular command, right? So in that way you can smoothen the textures, and it is very useful command, guys. You will for sure you will required in while pre-processing the 3D printing. Got it? Otherwise, if you are using the FDM 3D printer, or obviously it is already giving a bad, not that good structure like resin, so pre-processing is required. So these are the brush. Another important icon here is very much, I think it may required while pre-processing. Flatten is okay. Flat to ho jata hai isse. Another important here is move command. Move command. Many a times, not only for this medical purpose, if you have some geometry, like here is condyle, right? If you would like to change the what we can say side or this particular geometry, can you move it or bend it? Not, but with the help of this move command, you can just translate it. So you have that provision, means you have that little flexibility, means you can move. Right? See this. Right? So whenever it means whenever you required, okay, I'm just explaining it for you. Right? Huh. So then all those are not that much important. Okay, then huh. Another one of the command is very much useful is edit. Sculpt ho gaya. Edit. Many times when we import, when we scan the whole skull or whole body. Usually, whenever we receive the file from the radiologist or doctors, the is of whole body, but we required only specific area, right? We required only specific area, whether it is mandible, whether it is jaw, maxilla, ear, whatever. So at that time, cutting operations, cutting operation is required. So there is an option edit. Just you can directly use plane cut. Okay, plane cut, and you can move it as you required. Like if you required half section, you can get it. Say this. Okay, if you required only tooth profile, you don't you're not that those condyle regions, if it is not required, and is in if in 3D printing, if you know the material consumption and time requirement is more that those parameters are very much important, right? So unnecessary things every time you would like to avoid, right? So in that at that particular requirement, you will need this cut command, right? So just flip it, accept it. So only tooth profile you will you can get it, right? It will be very useful command for you guys, right? Next. So another here, one another command is so select. Hello. If you would like to process something on specific that particular region, so you need to select that specific area, right? So how you can select those area? From select command, select. So you can keep predefine the size of brush, and you can select that particular area. Like if you are aware the surgical guide, right? Surgical guide. Hope you are aware the surgical guide I have shown in my last presentation, or you can in other presentation also you have seen. For surgical guide, we required the support structure on that particular tooth area where we are going to place that implant, right? Implant. So while such application or such requirement, you need you may require the selection of that particular area. Help of select command, you can get it. But remember, after selecting this, you can see the boundary. It is irregular, right? It is not smooth. So after selection, there is an edit option. Sorry, modify option is there. After selecting that particular area or target, there is a modify option. Just click on smooth boundary. Okay, you can see the difference, right? You can observe the difference. Huh? So after smooth boundary, it smoothen that particular section. Right? In that way, you can use that particular command. So here we are taking this example further. So there is a we have seen the what of just after that, if you would like to separate this particular geometry as an individual STL, right? Last time some of the participant asked me about सर एक अर्जंट सेशन मध्ये आहे इम्पॉर्टंट मीटिंग मध्ये मी कॉल बॅक करतो हा मी कॉल बॅक करतो hello like here you want only to 3D print only tooth or a particular section, and so how you can get it by plain command cut command. You can separate it out, but there is if you have selected that particular geometry, there is an option, separate option is there. Okay, what you would like to do, just select particular geometry, whatever the section is there, and you would like to create a separate STL, right? Separate STL of it, right? So what you need to do, select that particular geometry, that particular area, then click on edit, and then there is a separate option, separate, or there is a shortcut key Y. Okay, just see, I'm clicking on that separate command. See this object browser, it converts into two STL, two parts, right? So in that way you can divide that particular geometry into two segment, right? It will be useful in surgical guide, in aligners, even application for surgical plannings. You may require this particular commands, and this is also important, object browser. Okay, object browser, and you can delete it from here, just like I'm deleting now. See, that part can delete from it here. Now if you required surgical like we are discussing the surgical guide, just we need to extrude that particular section offset that particular section and we can get that cap, right? We will get that particular capping for surgical guide, right? But if we would like to get that implant, or we required any hole in this particular geometry, or we would like to add something over here, so how we can pre-process or process that? So see, observe this carefully. There are some predefined primitive. You can see this. There are numbers, there are arms or other parts, right? There are other geometry also. If we are taking this here probably. Number. Okay. I have imported that one of the predefined one primitive, like one number, right? Many times, in various models, numbering, we can do it with the help of this software itself. So another command I'm telling you, for here to move those STL file in this particular environment, you will need a transformation to transform that STL file from one place to another, whether it is translation, whether it is rotation, those operation will required here. So you can directly get it from edit option, or just click on T, select that particular STL and select the T button. So you will appear that transform command. So see this, there is a x-axis, y-axis and z-axis. Okay, so you can move along that particular axis. See this, how I am operating. Right, you can rotate it also, and you can change the view, like here is the top view, side view. You can change those view. Huh? Like now I would like to change the view. Okay. Now here itself, like as I told you, you can rotate. You can rotate and in any direction. You can move, change the position in any direction. At the same time, you can scale it down, or means you can enlarge or reduce that particular profile. Okay, so you can scale from here also, x-axis, y-axis, z-axis. You can see. Okay, or there is a option. There is a rectangle. You can see rectangle, green rectangle, red rectangle. Along that particular axis, every axis, there is a rectangle mentioned on that particular arrow. So you can click, right click on that, and you just drag. So in proportion way, that particular geometry will scale. Even you can engrave your name also, that particular part, name, number, whatever it may be. Okay, or you can add another STL here with the help of Boolean operations, right? Accept. Whatever. So if you would like to it is not a meaningful geometry to show you the reduce command, means Boolean operation for subtraction, but still I am if you would like to remove that one, take example of any another shape, but if you would like to remove that particular area from that another body, just you need to select that entity and then another entity, then you can see the Boolean operation or other operations will appear. Like they will ask, are you getting the process? Just you need to select those both STL, right? Then that particular software will ask what you would like to do, whether you would like to merge those STL into a single part, or whether you would like to remove that particular area of that particular STL from the another. So hope you are well aware of the Boolean operation, right? So you can do that particular Boolean operation with the help of this software, right? The preference is very much important while selecting this Boolean operation. Subtraction. Acha. The profile was that one primitive which we have imported from predefined library is not completely solid, right? Many times various error may appear, right? Okay, now edit once again. Okay, just now. So hope you got any just introductory information about this mesh mixer. We have very less time, just 5 to 10 minutes. I'm hope you got some little bit information or overview about. So dedicatedly we can plan a session. It will take much time, but we don't. Right now you can like a blender, you can render those STL file from here. You can as I told you, most of the STL files which we are used to download from Thingiverse or Thingiverse, those are corrupted files. So from this software itself, you can inspect, analysis, and repair. Repair is very important thing. So there is an analysis option. Analysis. So you can inspect analysis also. You can inspect whether your geometry is good or not. You can see here, as I have clicked on analysis and inspector, it is showing one error in this particular file, right? So directly you can click on that balloon, or directly you can click on auto repair. Okay, see, it will get repaired. So this option, this tool is also important, analysis tool, right? So that otherwise what will happen, your manufacturing or 3D printing will get affected if there is an error in your STL. So you need to check printing. Okay, for that inspector command will be very useful. Many times you would like to measure in slicing software, there is no option to measure the edges or size, thickness, but here in mesh mixer there is a option measure. You can measure the distances from one point to another point, from one edge to another edge, like thickness. All those things you can do from this analysis tool of this mesh mixer, right? It is very useful. Another, as I told you about the plane cut, right? Mirror. Hope you have remember my earlier session just one day before. I have shown case study of ear, right? Ear. Many times the symmetric structure we required, but we are not generating the thing from engineering CAD, right? In engineering CAD there is a mirror command, but if we are directly getting STL or directly getting the DICOM data, how we can mirror? So this is the best platform if we require the mirroring or symmetrical thing, right? So in edit option, there is a mirror. In that particular case, we have scanned the one side of ear and we have received STL of that good, healthy ear. And one another ear was defective, right? So with the help of mesh mixer itself, we have created the mirror of that geometry, right? And then we have created the mirror geometry, and then we have proceed for the 3D printing, right? So mirror option is there. Duplicate option means number of file you can generate. Another make solid and make hollow. This is also important option. If you are aware that CT scan data, CT scan or reverse engineering means scanner which are, whether it is handheld EVA scanner or David scanner, whichever scanners are there in market, those are external scanner, blue light or white light, whichever scanner technology is there. They are surface scanning. They are surface scanners, right? So but here, as you know, in 3D slicer or 3D printing, you know, you need the solid geometry. Even in FEA also, what if you are going for analysis, we not only require the surface, we need a solid geometry. With the help of these tools, you can make any geometry on any STL solid or any hollow. Got it? So those pre-processing also you can operate over here, right? In this particular environment itself. Shader, so I told you the rendering coloring you can give the this particular STL, right? Next, just 5 minutes I'm discussing last 5 minutes. Sure. Is it visible?
Yes, sir.
Yeah. As I have given the introductory overview about that pre-processing tool, about mesh mixer. Another is 3D slicer. Why we are discussing this? To avoid those errors, avoid those issues while 3D printing, right? So slicer, slicing software, if you have gone through, we need to export that particular STL, which we have means updated STL, corrected STL from mesh mixer into slicer to generate a G code. Here also, remember about the parameters. Hope I think parameters किसी session में आपको हुआ होगा about the orientation. The Cura software you are aware. This is the open source softwares you can use. Various proprietary softwares are there. Means every 3D printer is come up with their own software, slicing software, right? So orientation in pre-processing, orientation of your STL file is very much important. And guys, for medical or dental applications, accuracy is much important, right? So you know, you have what we have gone through various fundamentals that we required the support for the overhanging structure. So as per that particular need, you need to rotate, you need to place, right? You need to place your particular geometry, how you are going to orient it, not only for to get the better accuracy, to get the better accuracy. Why I'm saying? Because whenever there is a support, see, if this particular area, if this particular area is our targeted area, we can't keep the position like this. Why? Because it will take the support. And where after at the time of post processing, means after 3D printing, we need to remove that support, and that's why the accuracy may affect. So this orientation is very much important to remember. Why before 3D printing, the orientation, which what is the targeted area, and what what is the our requirement. Even that orientation is very much important for the time and material consumptions, so that your support will be reduced, and ultimately time will be reduced, right? At the same time, accuracy, I'm not discussing in much, but height, if you required only prototyping, that accuracy doesn't matter. You can print on 300 microns, 200 microns, but when you required the accuracy, so after obviously you can give it from here. Say fill density, right? Means infill, means you want completely solid or partial solid. It depends on the finally the requirement, whether it is required, the strength requirement is there, right? Or just only prototyping requirement is there. So all those pre-processing you can do for in this slicing software. Some of the slicing software don't offers any editing related things. Even Cheetu box is there, which is add-on to those resin printers, right? So all those processing you need to carry on this in this slicing softwares, right? So तीन बज गए, I know, Achar. This is from my side. Ravi sir, I think
Yeah,
you are being late for quiz
yes,
and valedictory, so I am
yeah.
summing up in short
No, no,
duration.
no. Thank
Yeah.
you so much, sir.
Yeah.
Thank you, Abhi, sir. I think I'm audible to you.
Yes, sir. Yes, sir. You're audible.
Your valuable time, and your both sessions were really very extraordinary, and we hope that our participants are going to be benefited out of it. Yeah,
Yes.
so thanks a lot for your valuable time and just engaging our participants on the theme of the FDP. Thank you so much, sir, for
Thank
being
you.
here. Thanks a lot.
Yeah. Yeah. Thank you very much, sir. And all the best to
Yeah.
all participants, and congratulations to you and your team, sir. Thank you.
Yeah.
Good day, sir.
So much. Thank you so much. So dear participants, we have concluded the last talk expert session here. So with us now, our coordinator, Dr. Pankaj Salo sir is here. Sir, am I audible to you?
Yes, yeah, Dr. Ravi, I can hear you.
Yeah. So Pankaj sir, as we have already planned that now onwards, we are just going for valedictory session, and then we will share the link with our participants for the test quiz. So I request you to just please just say some words, motivational words to our participants so that our validity can be compiled up. Please, sir.
Yes, oh, okay. Thank you, Dr. Ravi, and thank you, Professor Abhijit. So now we are in the valedictory session. So I welcome you formally all the participants, all the coordinators, and all the faculties, those who have joined from the within our institute or maybe outside institute. And so when I see this FDP, the 6 days, this has been very enriching experience for us also. This is the sponsored FDP, and the expert, if I say, all the expert were from the diverse field and from the academia, from the industries, and they have shared the knowledge from the related to the additive manufacturing or 3D printing, focusing mainly on the biomedical applications. So that has been very useful for our participants. And this, I think FDP will be very useful in a terms to connect with each other, because these sort of course help for a long run. So all the participants, if they have any, let's say maybe query, or maybe they want to work in a different areas, they can directly connect to the maybe the esteemed speakers, whatever, let's say, knowledge they have shared. They can contact through the email IDs. I think all the speakers has shared the email IDs, or maybe our participant can search on the internet also their name. Nowadays, that is very easy to get the contact details. Overall, I would also like to thanks our supporting staff, also the coordinators all involved in this FDP, all the resource person, our experts, all the participant. Also, I would like to thanks our director sir, Professor B.V. Ramana Reddy, our head of the department, Professor Hari Singh, and these all have supported at all the stages. And now the participant for this test link, I think that will be shared on the chat box. Let me just check if it has been shared or not. Yeah, I think that will be shared very soon. Yeah. So if you have any, let's say maybe feedback in terms of just your experience, how this has been useful for you, you can maybe also put on the chat box, or maybe you can unmute if you want any one of participant.
Yeah, definitely, Dr. Pankaj, sir. It will be more appreciable if directly just participants can unmute themselves and just say some words about as a feedback of this FDP, please.
Yes, yes.
Sir, good evening. Can you hear me, sir? This is Dr. Rajkumar.
Yeah, good evening, sir. We can hear you. Please go ahead.
Sir, I am working as a professor in Care College of Engineering, Tiruchirappalli. This FDP is very useful for me as well as the other participants as well. Because we thought about this 3D printing in terms of UG level, as well as applications are also limited within our scope of research area, my research area. But after attending your FDP, the scope is more, and this 3D printing is very much essential for producing products in terms of medical applications. I have to thank all the resource persons as well as the coordinators for arranging this FDP. Thank you so much, sir.
Thank you so much for your valuable words for us. Any other participant? You can unmute.
Hello,
and you
sir.
can.
Good evening, sir.
Good evening.
So myself, Dr. Navya from Bangalore, working as Associate Dean for R&D at Nagarjuna College. So today's sessions were very useful, sir, especially when with respect to biomedical application. This morning, Ramesh ji had explained us in detail about how to use this bioceramics in medical field. Like even I am working for two tissue engineering. So that session was very useful and all my queries got solved there. So thank you so much for this, sir.
Most welcome. Thank you. Any other participant? So participant, you can unmute yourself and you can say maybe a few words as a learning outcome, and how was your experience for this FDP?
Yes, please, dear participants, come ahead and just say some words about the FDP. So it will be like a feedback for us. If any improvement are required, so definitely we will try to do that in coming FDP and courses also. Please.
I think means they maybe have filled the feedback directly on the portal. I think. Yeah.
Definitely, sir. They will fill up over the ATAL portal. Okay, Dr. Pankaj, sir, what I feel that it's a time to circulate the link for test quiz so our participant can appear for that.
Yes, yes.
Yeah, and dear participant, good luck for your this particular test. Just go ahead and just attempt. Recently, just now we are just going to circulate that link with you all on all the platforms, whether it is WebEx chat box and WhatsApp and YouTube as well. And one more thing to highlight again and again, that it will take a few days to us to just compile your attendance and to feed up the test marks on the ATAL portal. Then only you will be allowed to submit your feedbacks. Then directly you will be able to download your certificate. Okay. So please be patient as you have been here from last 5 to 6 days. So thanks a lot for your kind cooperation and throughout this engagement during this FDP. Thanks a lot. The link is just to be shared very soon. Please. Thank you all. Thanks a lot.
Yes, yes. So Ravi sir, link will get on this only now. So participant has to wait.
Just
They will
our
copy.
team is just our team is just sharing
Yeah,
now
yeah,
here chat box, WhatsApp, and YouTube on 3 platform. The link will be provided.
Yes, it is there now. I can also see on the
Yeah.
chat box.
Yeah.
So yeah.
And it is
So
for
link
30
has-
minutes. 30-minute
Hmm.
time is here. So please manage accordingly.
Yes, it's visible.
Sir, Rathi sir, Rathod sir, Single sir, all are here being present during the validity session. I'm very delighted and thankful for you all. On this weekend, you are here to motivate us and motivate our participants. Thanks a lot, sir, for being here. Thank you so much.
Yes, thank you everyone.
Right.